Hey everyone, and welcome to this explainer. Today, we are going to take the Chrome DevTools Network tab, which, let's be honest, usually just looks like a developer-only wall of text, and transform it into your absolute ultimate magnifying glass. If you're an IT support engineer, you are dealing with complex web applications every single day, and the ability to perform high-resolution network forensics, well, it's no longer optional, it's a mandatory competency. By the end of our time together, you're going to know exactly how to use this tool to track down the most elusive bugs. Oh, and if you want to follow along, you can practice these techniques using Chrome on literally any public website, or just head over to httpbin.org.
We've all seen this exact ticket, right? The page is slow, or maybe it didn't work. And that's it. That's the whole ticket. No error codes, no steps to reproduce, just a really vague complaint from a super frustrated user. This is the universal pain point we face daily. And you know, it usually just leads to this agonizing back and forth, begging for screenshots that rarely actually show the underlying issue.
But this right here highlights the night and day difference between the old way of doing things and the modern support workflow. The old way is basically just guessing at a random API issue, blindly clearing your cache, and, crossing your fingers. But the new way? You open DevTools and you see the exact 500 error payload, the specific HTTP status code, and the response headers with absolute certainty. It's a total game changer. You transition from guessing to knowing.
So here's our game plan. We'll uncover the hidden debugging tab, learn how to filter out the network noise, read headers and payloads, deconstruct network latency, and then we'll tackle a real-world scenario involving slow pages.
Section 1. The Hidden Debugging tab. So, what actually is the network panel? Officially, it's defined as the primary telemetry interface in Chrome DevTools. Its sole job is to capture an exhaustive, play-by-play record of every single packet transaction between the user's browser and the server. Think of it as a completely transparent window into the browser's communication layer. But here's a super vital tip. To make sure you capture the full dataset, you absolutely must have this panel open before the requests happen. Otherwise, you're going to need to do a full-page reload while the inspector is sitting there active.
Section 2. Filtering the network noise.
Modern web pages are loud. They trigger hundreds of individual requests for scripts, tracking pixels, fonts, you name it. So how do we find the needle in that massive haystack? Well, you can immediately cut out the irrelevant noise using the tactile buttons at the top, the resource type bar. Hunting down a broken form submission? Just click fetch/xhr to isolate your API requests from all those background images. Need to check if a specific script is loading? Click JS. And here's a really cool pro tip. You can multi-select by holding down Command on a Mac or Control on Windows. That lets you view both JS and XHR simultaneously, so you can perfectly observe how a script's execution correlates with the data it's fetching.
Now, what's really fascinating is how property-based filtering allows you to query metadata with surgical precision. If you just type domain followed by your API's URL, boom, you instantly hide all that third-party CDN noise. Looking for broken links? Typing status code 404 will immediately expose any missing assets. You can even filter by method, post, to monitor specific data submissions. It is incredibly powerful once you get the hang of it.
Section 3. Reading headers and payloads.
All right, so you've found your target request. Now it's time to inspect its precise anatomy. When you click on a request, a detail pane opens up, and that Headers tab is your definitive, undeniable record of the HTTP transaction. Request headers show exactly what the browser asked for, while response headers show how the server actually replied. If you ever hit a CORS error, this is exactly where you look to see if the server permitted the origin. Plus, the Preview tab takes complex JSON response bodies and formats them into really nice, readable trees. But don't ignore the Response tab. That gives you the raw server output. Sometimes, a server will send a cheeky 200 OK status, but the actual critical error message is hiding right there in the raw response body.
Section 4. Deconstructing network latency. Let's shift our focus from what the data is to how long it takes to travel using the waterfall chart. A network request isn't just one single event. Actually, scratch that, it's more like a sequential dance. First, the browser does a DNS lookup to find the IP address. Then, it establishes the initial connection, the TCP handshake. Next up is the SSL negotiation to make sure everything is secure. Then comes a highly critical phase, waiting, also known as time to first byte. And finally, the content download phase kicks in when the data actually streams to the browser.
So out of all that, here is the smoking gun you're looking for: time to first byte. If this waiting phase stretches past 200 milliseconds, your server or database is the culprit, for sure. The browser's asked for the data and is literally just sitting there twiddling its thumbs, waiting for the backend to think. On the flip side, if the content download phase is massive, then the file size is just too big or the user's bandwidth is seriously constrained.
Section 5. Real scenario, slow pages.
Okay, let's bring all these incredible tools together and solve that vague "page is slow" ticket we talked about earlier. Now, as an engineer, you're probably sitting on a blazing fast gigabit connection. To genuinely reproduce the user's issue, you have to level the playing field. Chrome DevTools includes a throttling engine that doesn't just cap your bandwidth, it actually simulates real-world latency. You absolutely must use these network throttling profiles to recreate the user's degraded network environment. By simulating a slow 3G connection, you get to see how the page actually behaves out there in the wild.
So here's the hands-on, over-the-shoulder look at investigating this latency issue. First, enable that slow 3G profile. Then, reload the page or trigger the action. Now watch that waterfall chart like a hawk. You are looking for what we call staircase dependency chains, where one request is stubbornly waiting for another to finish before it can even start. You're hunting specifically for non-critical assets that somehow got assigned a high priority and are literally blocking the page from visually rendering.
And boom! Here is our aha moment. As we watch the waterfall under that slow 3G throttling, we spot a single, glaringly red highlighted block. A completely silent third-party analytics script was sitting right smack in the middle of our critical rendering path, adding exactly 2.4 seconds of blocking time. The server was fast, the user's connection was actually fine, but this one little misconfigured script was halting the entire page load for 2.4 seconds before letting any content render. We found the ghost in the machine.
Okay, so you found the culprit and proved the issue. How do you hand this off to the developers? Please, whatever you do, don't take an awkward screenshot. Instead, right-click that failing 2.4-second request and hit copy as CURL. Or even better, use the export button to generate a full HTTP archive, an HTTP archive. When you attach these exact artifacts to your Jira ticket, you are handing the engineering team the ability to replay the exact request-response cycle. You are perfectly packaging concrete, undeniable evidence so developers can reproduce and fix the bug with absolutely zero pushback.
Think about what we just did. We took that chaotic wall of noise in the Network tab and turned it into a structured, highly analytical instrument for uncovering the truth. You now know how to filter with precision, read the raw payloads, deconstruct latency step by step, and capture irrefutable proof of a bug. So the next time you get a ticket complaining that the page is slow, I want you to ask yourself, what hidden bottlenecks will you uncover? Open up DevTools and go transition from guessing to proving. Thanks so much for joining me on this explainer, and hey, happy debugging!